Hi, good day to all of you. My name is Rama from PUB. I'd like to share a little bit on the GIC challenge on building practical 3D printing capabilities for water utility applications. We've seen 3D printing taking a good spot in many other sectors, for example, medical or even in the construction industry. But not so much yet in water utilities. That's what we're trying to do via this challenge. As a background, we need constant maintenance and vigilance of the activities in the water infrastructure so that we can continue to give uninterrupted service to our customers. One of the challenges here is to maintain a resilient supply chain for ready access to spare parts. While we have a good inventory system in PUB to plan and track our spare parts, we do sometimes meet unexpected challenges, especially when you have unexpected failures, right? Then the items run out, and rapid manufacturing capability for on-demand production, that would help with better resilience. And we think 3D printing is a way in that direction. We are looking at some areas of opportunity here. One is to integrate 3D printing into our operational and maintenance strategies to enhance our response. For example, in repairing leaks in special fittings or custom-made pipe sections, which are not readily available. Is also to have an alternative to the present external supply chain, which is sometimes vulnerable to maybe things like pandemic and so on. These will help us minimize our disruption or downtimes. The second aspect we're looking at is to have smart equipment or components, right? And we want to have this capability to be either done in-house or locally in Singapore. We are looking for partners with proven expertise and experience whom we can work with to develop these practical solutions towards the water industry. We're looking at trying to develop capabilities in having accurate digital models of components from a physical item through 3D scanning technology. And then we can use this to as a digital inventory for critical parts and print the parts on demand. We're also looking at getting this 3D printing systems deliver consistent, high quality components, right? Optimizing lead time. Together with this, we would need to have the relevant expertise in material science and post-processing methods so that the printed components will meet our functional needs in the water industry. So in submitting your proposals, we would like you to actually include information related to the proposed components, right, for this pilot project. To give an indication, PUB has highlighted some of these here. We are looking at maybe pump impellers, pump wear rings, also pipes and fittings that are customized or specialized, unusual sizes or unusual shapes and sections. Other information to be included in your proposal will be material options or alternatives that can be considered, just to ensure that these materials are compatible with water and wastewater applications. They also must be able to meet the performance requirement of the equipment as well as the service life. Do include details of any hardware and software specific ones that need to be employed in the process for production. When you talk about for the novel applications, please provide a comparison between the 3D printed approach and the conventional approach, and also on how you do testing, commissioning, and functional verification for the products printed up. In terms of system requirements, we are looking at printing size as one element. We're looking at printing parts of up to 1 meter by 1 meter by 1 meter. If that's not possible, do indicate the max size that you can print. For scanner, we want the capability to be precise enough to do geometries as complicated, probably as complex as pump impellers. The system should be optimizable based on certain parameters and should be able to meet the Singapore workplace safety regulations for indoor usage. The parts printed will have to be evaluated based on dimensional accuracy, structural integrity, and durability. Our expected outcomes for this project, within a period of 18 months, we hope that we can achieve, if not both, at least one of the two key objectives. The first is to establish an end-to-end process for on-demand production of spare parts. And the second, other innovative 3D printing applications with smart features for water utility operations. For the on-demand production of spare parts outcome, the solution must be able to demonstrate accurate reproduction of the components from the sample or from 3D models, a good conversion of the parts into a printable 3D file, reliable operation with minimum operator intervention to produce the parts within 2 to 3 days, verification and adequacy of structural integrity with testing over a minimum period of 6 months, and if there is any relevant certification or standards, then the testing to meet those standards, and to implement a digital parts repository system using the 3D models for managing the 3D models. For this outcome, the PUB will provide the relevant samples and, where possible, to support development or testing. For the second desired outcome on innovative 3D printing applications for water utility operations, we're really trying to leverage on your experience, exposure in this field, your domain area, on what kind of smart products, probably sensor embedded products, or embedding sensors into our parts that we can actually print and use in our applications for better benefits. For example, pipe sections with embedded pressure sensors to detect pressure anomalies, or maybe impellers with embedded sensors to detect impending failure or wear and tear, or anything else that you may have come across in other industries that could be adapted for us. And for these products, we would like you to come up with a proposal of what the product will be, what kind of features can be incorporated, and how do we test and commission these, verifying the functional capabilities before deployment. Do also highlight the benefits that we can derive from such product deployment. Well, that brings me to the end of what I had prepared to share with you. We look forward to receiving enthusiastic, interesting proposals from you. But before that, let's address any questions that you may have. And I will try to help you as much as I can on that to clarify it. Thank you.